Hi guys, this is Mr. Vandergriff, and I just wanted to do a quick review of what is the difference between an independent versus a dependent variable when it comes to designing a scientific investigation. So first, the independent variable is the thing that you were testing. It's usually abbreviated IV, of course, for independent variable. It's also called the manipulated variable, the thing that will be changing. And it's the cause or the if part of your hypothesis. So keep that in mind. Now, on the other hand, the dependent variable is the thing that you are measuring. So that is a lot of times abbreviated DV. It's also called the responding variable because it is dependent on the independent variable. This is usually the effect or the then part of the hypothesis. So let me give you a little quiz and see how well you do on this. Which is the independent variable and which is the dependent variable in these examples? So here's a hypothesis. If students study 15 minutes a night, then they will have higher test scores than those who don't study. What is being changed or manipulated in this situation? Think about it. Well, it's did the students study or not? It's the study time. So for instance, students could study 15 minutes, or maybe they would study 30 minutes, or maybe they studied 45 minutes, or maybe they studied 60 minutes. And what's being measured? Their grade, their score, how well they are going to do on the test, whether they get a C or a B or an A. So if you take a look in this experiment, the independent variable would be the study time, like we mentioned, 15 minutes or 30 minutes or 45 minutes. And the dependent variable is the test grade or the test score. So the longer they study, you would hope to see that the grade would go up. So again, like, how would you graph something like this? So let's take a look here. So let's draw here. So again, what axis is this? Yeah, that's the x-axis. And you always put the independent variable on the x-axis. And the y-axis, you're always going to be putting the dependent variable. So in this case, it was study time, right? Study time, or minutes. So we could say 15 minutes here, 30 minutes, 45 minutes, and 60 minutes. And then over here, what would go over here, right? That would actually go the grade. Okay, and that, let's just start here. We'll start with a C, and a B, oops, and an A. So again, maybe we'd see something like this. I'm not sure. You know, the longer you study, the higher the test score. Not sure because we haven't done that experiment, but that's kind of how you would graph it. So hopefully that helps. All right, let's go back. Jump into our presentation. Second hypothesis. This is another investigation. If people who have headaches take aspirin, then they will get relief faster than those who don't. Again, what is being changed or manipulated? Because that's going to be the independent variable, right? It's going to be, are they taking aspirin or not? Or how many? And then what's the thing that's being observed or measured? That's going to be, is the headache going away, and the time it takes for the headache to go away. So the independent variable is going to be if someone is taking an aspirin, maybe they would take 1 aspirin or 2 aspirin or 3 aspirin, right? The independent variable, or excuse me, the dependent variable would be how long it takes for the headache to go away. So how would you graph this one? Let's go back over here. And we draw our what? Our x-axis, our y-axis here. What is this? Yep, this is going to be our independent variable. And our dependent variable is our y-axis. Here and here. And this one was, remember, aspirin, so maybe 0 aspirin, maybe 1 aspirin, maybe 1.5 aspirin, maybe 2 aspirin, and maybe 2.5 aspirin. Probably don't want to take any more than that. Might not be good to overdose with aspirin, right? And then over here would be time. So let's say 5 minutes. Over here might be 10 minutes until the headache disappears. 15, maybe 20, 25 minutes. So we need to put minutes here. Minutes it takes for the headache to go away. What's down here? This is going to be the amount of aspirin. Alright? Okay, it's really hard to write with this. But again, if these aspirin really do work, right, and the time, so I would think maybe it would look something like this. Maybe up here you don't take any, it's going to take a while, but then the more you take, your headache disappears a little quicker. So it might look something like that. Let's clear this. Let's go back, jump into our presentation. Let's go to our next experiment. Hypothesis: if a name brand light bulb is left on, then it will burn longer than a bargain brand or a budget brand light bulb. What is being changed or manipulated? It's going to be the quality or the type of light bulb. So that's going to be the independent variable. The dependent variable, what's being measured, is how many hours that light bulb is going to last. So again, independent variable, type of light bulb, right? Dependent variable, how many hours the light bulb works before it burns out. So again, how do we graph this? Let's go ahead and take a look. Over here, what are we going to have on the x-axis? You guessed it, this is going to be our independent variable. And this is going to be our dependent variable, the y-axis. Here, y-axis. This is going to be the brand of light bulb, right? Brands of light bulbs. So, I don't know. You just put light bulb 1 brand, or actually we could put letters like A and B and then C and then D. And we probably want to not know the brands of the light bulb so we're not biased, right? So we would just put letters on those, and then here's going to be maybe 20 hours, maybe 40 hours, or maybe actually this should be 200 hours, and that should be 400 hours, and that should be 600 hours, and this should be 800 hours. And again, so these are hours here, or time and hours, right? Time, and that's the y-axis. And again, I don't know, we'll see, maybe it'd be, something like this, we don't know. And then we would have to analyze and see, is this the most expensive one, and did it last the longest? And then we would, maybe predict that the one that lasted the least amount of hours would be the cheapest one. So like this is maybe the cheapest, and this here would be the most expensive brand. But again, we don't know. We have to see our results. Okay? Let's do just a couple more here. Hopefully this is helping you have a better understanding of the difference between independent and dependent variables. All right, here we go. Hypothesis. If we expose plants to different amounts of cigarette smoke, then the plants exposed to the cigarette smoke will develop poor health, or the plants that are exposed to more cigarette smoke. So what is being changed or manipulated? It's going to be the amount of cigarette smoke that the plants are exposed to. What's being observed? is the health of the plant. So again, we're going to have to come up with some type of rating if the leaves are shriveling up or if it's stunning the growth, but we're measuring the health of the plant. So the independent variable is the amount of smoke, and the dependent variable is the health of the plants. So how would we graph this? Well, first, let's just really quick here show you, because I did have a student do this before. So let's say that we had plant here, and plant here, and plant here. And let's say in here there is absolutely no smoke, no cigarette smoke. Alright. This is going to be our control. And then over here is going to be our experimental group. And the plants need to start up at the same height. They need to be as healthy. And this one's going to be smoke. Okay. So let's say there's a little opening in here and we can put smoke in here once a day and fill this up with smoke. And let's say after, I don't know, is that not gonna, let's say after 10 days all the plants are dead. Have we proved anything? Absolutely not. Maybe the person that was doing the experiment forgot to water. Or maybe they put the plants in a dark place in their room and it died because they didn't get enough sunlight. The only way we're going to know and prove something is that if we have a control group and at the end of the experiment these plants are looking healthy and these plants are looking sick. The only difference between these two would be no smoke and smoke. They each need the same amount of water. They each need the same amount of soil. They each need the same amount of sunlight. They each need to be in the same temperature, in the same environment. Because what if the plants here died as well? Well, then we know the smoke didn't kill the plants. It was something else that killed these plants. So it's always important that we have a control. Now, how would we graph this? Our x here, our y here. This is going to be our independent variable. This is going to be our dependent variable. And what's going to be here? This is going to be the amount of smoke. So let's say the plants get the smoke from one cigarette. Like we light the cigarette, we put it in the dirt, and we let it burn all the way down and fill it up with smoke. Or let's say that one enclosure, it gets 2 cigarettes a day, or 3 cigarettes a day, or the smoke from that, or 4 cigarettes a day. And then up here is going to be the health of the plant. So this is going to be the health of the plant, and this is going to be number of cigarettes here, or the number of cigarettes smoke. Okay. So how could we do the health? Maybe we would say that this one looks like, maybe we're looking just overall, we have a rating system, and this one looks healthy, looks 10% healthy. This one looks 20% healthy. This one looks 30% healthy. It goes all the way up to 100% healthy, and we'd have to have some type of rubric to determine that. So we might see again something like this. If this is 100% health up here, that it's going to be healthier, and the more cigarette smoke right here, it would be getting more sickly or not as healthy. Again, that's just an idea. Hopefully that helps there. Let's do, I think we had a couple more here. Alright, this one here, if we did 6 types of paper towels, then I predict the most expensive paper towel would be the most absorbent. What is being changed or manipulated? The brands of paper towels. What's being observed? How much water or liquid the paper towel can absorb. So again, independent variable is going to be brands. Dependent variable is going to be how much water the paper towels are going to be absorbing. Again, very easy here. This is X, this is Y, this is the amount of millimeters of liquid that's absorbed, right? So maybe 5, 10, 15, maybe 20 milliliters of liquid. And down here is going to be brand A, brand B, brand C of paper towels, and brand D. Right? And I think I've got one more left. Let's take a look here. This one has to do with fertilizer. If we give plants different amounts of fertilizer, then I predict the plant that receives the most fertilizer will grow the tallest. So, whoops. Let's see here. So again, please explain what's the independent variable and the dependent variable. How do you know? How would you graph the results? Let's take a look here. This is our last one. Yep, this is X and this is Y. Where does the independent variable go? On the X. Where does the dependent variable go? Now, what is the independent variable? It's going to be the amount of fertilizer. I'll just put fertilizer. Oops, right there. So maybe 1 spoonful, maybe 2 spoonfuls, 2 spoonfuls of fertilizer, maybe 3 and 4 and maybe 5 spoonfuls. And again, it might be better to measure these in grams. We weigh them out in the scale, be a little more scientific. And then up here, I think it said the height of the plant. So maybe, let's say they start out at 10 centimeters. So this is going to be the height of plant. Okay? And maybe 20 centimeters, 30 centimeters, 40 centimeters. And again, we don't know what the results are going to be, but maybe right here that the more fertilizer, it gets taller, but maybe there's some point where it gets too much and it actually starts to stunt its growth. So let me clear this here, foreground there, and there. So hopefully you have a better idea from this video. You've done some practice. I know it's a little long, but I think it's very, very important that you know the difference between the independent variable and the dependent variable when it comes to scientific investigation. Last thing I just wanted to point out here is when you make a data table right here. So let's say in this last one it was the amount of fertilizer. So it was the amount of fertilizer. And then the other one was the what? It was the height, and it was in centimeters, right? So, oops. So this is our data table. I do believe that when you make a table like this first column is always going to be your independent variable. Your second column is always going to be your dependent variable. Again, so if you take this table and turn it into a graph, your independent variable is going to be here on the X, and your dependent variable is going to be on the Y. So then you would graph, as you graph it, these numbers would go here, and if you graph it, these numbers would go right here. So that's the correct way to actually create a scientific table to collect your data and where you're supposed to put the independent variable and the dependent variable. So I hope that you found this video helpful in reviewing independent variables.